All right, so in this video, we're going to have a look over compound interest. And this video is being made specifically to support your assignments that you're working on at the moment, which is financial mathematics and looking at compound interest. So let's dive right into it and see what it is we're going to be looking at. So what is compound interest? Let's deal with that first. So as you can see, it says on the screen, compound interest is interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. In my oversimplified mathematical brain, what that basically means is it's a form of interest that is calculated on an increasing amount or number, okay, not just a lump sum. So typically when you've had simple interest before, it's a lump sum. Compound interest is based on an increasing sum of money. So for example, you might see that when they do the interest calculation for compound interest, it's taken a couple of times a year, and that the interest is calculated on whatever an amount has grown to. So if something is increasing by 5% and it was compounded multiple times, it would mean that when the calculation was made, it was done on the increased figure as opposed to whatever it was initially. Okay, we'll have a look at what that looks like. So in an oversimplified way, compound interest is just an increasing interest that's calculated on a larger number. All right, but what is the formula? So here is our compound interest formula. So you have A equals P, brackets 1 plus R over N, close brackets, N times T. So to understand this formula, we need to know a few things. So firstly, we need to know that A is the final amount. We need to know that P is the principal, so the initially invested or paid amount. R is our interest rate. N is the number of times interest is applied annually. And then you have T, and that is how long the investment or loan lasts. Notice that it's NT, so it's N times T. Okay, that number of times interest is applied is really, really important to us. And when we express the rate, and I show this in the next slide, when we express the rate, we express it as a percentage out of 100. So for example, a 5% interest rate is not 5 over N, it's 0.05 over N. Okay, we need to do that conversion back to decimals. So let's look at an example quickly. So Brenda invests $4,848 in a savings account with a fixed annual interest rate of 5% compounded 2 times per year. What will the account balance be after 6 years? So the first step, and the most important step, I think, when you do any of these questions, is to define. Okay, define what your APRNT is going to be. Okay, so what is the amount, the principal, the rate, the compounded times, and the actual time frame of the investment? So in the question above, if we look at it, we are looking for A. We're looking for the amount. That remains unknown at this time. So let's have a look at what we can do. So first step, we're going to define. We know the principal. Okay, the principal said it was 4,848. The amount invested was 4,848. So we know what P is. The interest rate was 5%. And as you can see down there, R equals 5%. We need to express this as 0.05. Okay, we have to express it as decimals, not as a percentage. Compounding occurs twice annually, so N equals 2. All right, you're going to start to see language like this, twice annually. Annually, if you're unaware, means over the course of a year. Okay, so if it said it compounds quarterly, there are 4 quarters in a year. Obviously, it was 4 quarters anything, so quarters is going to be 4. If it says it was to be monthly, how many months are in a year? There's 12. All right, so that number will be 12. If it said it compounded fortnightly or weekly, you'd have 26 or 52. So it's important that you make those calculations or those numbers over an annual time frame. And the investment itself was over 6 years. Okay, so if you have a look at a breakdown, A, you don't know yet. You know the principal, you know the rate, you know it's compounding twice annually, and you know it's over a 6-year period. So if we actually look at the formula input, this is what we get. A equals 4848 times brackets 1 plus 0.05 over 2, closing brackets 2 times 6. So to break that down again, your amount is going to equal the principal, which is $4,848, being times by 1 plus your interest rate, again, expressed as decimals, not as just that percentage. So you can't just write 5 because it's 5%. You must express it as 0.05. Over 2, it's compounding twice annually. So that's your 2 in there. And it's times by, it's close brackets to the power of 2 times 6. So the amount of times it's compounded annually, which was that 2, times the length of the investment, which was over 6 years. Okay. Remember, when you actually look at the formula, it's expressed as NT. So if you actually look at that power at the back of the brackets, it's NT. You must remember to times them together. Okay. So again, Amount equals 4848 times 1 plus 0.05 over 2 to the power of 2 times 6. All right, let's solve it. So amount 4848 times 1 brackets 1 plus 0.05 over 2, close brackets, to the power of 2 times 6. Let's calculate it. So we end up with this a calculation, which is 4,848 times 1 plus 0.05 divided by 2, okay, to the power of 12. The 12 has come from the 2 times 6, which again, times we're compounding annually, times by the actual time frame of this investment. Next step down, 4,848 times brackets 1 plus 0.025 to the power of 12. Note that we have simplified that. We've done the division, so we divided 0.05 by 2. Be aware that we are solving everything inside the bracket before we apply the power to it. Okay, remembering the rules around BODMAS, you're dealing with things inside the bracket before you do anything outside of it. So don't do the multiplication outside of the bracket, or do your powers until you've solved that bracket. Okay, so when we add 1 to 0.025, we end up with that next line of the solution, which is 4,848 times brackets 1.025 to the power of 12. We can now do that calculation, 1.025 to the power of 12. And we have that A equals 4,848 times 1.839881. And so we have A is approximately equal to $8,911 and 0.439, which of course we would round up. So you might be asked to round it to, for example, 2 decimals, so we get 0.44. You might get asked to round it to the nearest dollar, which in this case, given it will be below 50 cents, would be 8,911. Okay, that is how we use compound interest. Often you get worded questions, so just jumping back a few slides. This again is the most important part. Stripping apart the worded question to figure out what information you know, write it out like this. When you do your tests, when you do your assignment, this is what I want your working out to look like underneath the worded questions if you do them. Have it very clearly defined what each component of that formula means and is equal to. And that brings us to the end of that. Okay, you can rewatch this as many times as you want. Ask your teachers in class, more than happy to help.